Hi, I'm Lars. Welcome back to the shop, or should I say my office, which means that we're going to be doing some stuff in Carveco or Fusion 360 before we go to the actual shop. This video is about the work origin and how we can manipulate it. Alright, so the other day I was working on some stuff in Fusion 360, some tests, and I created this little triangle and little circle. Nothing major. These are tests that you have to do to learn how to do things in a software and the machine and see how they actually work together. The big thing is that I had to make an adjustment, and minor adjustment, just wanted to change the depth of the holes and see how that could be done. So I went back into Fusion 360, made the adjustment that I needed to make, and then went back out to the machine. And I wanted to use the same board that I had. However, probing off this corner became an issue right now. So I could probe off it and I could cut the same hole, but I wouldn't see the difference in the holes, right? I actually wanted to have another hole cut. So either I could turn the board this way, and probe that one, or turn the board, upside down and probe off this corner or whatever. But I didn't want to do that. I wanted to use this hole, this corner. So what I did is I moved my work origin offset up to here and reran the same program. Okay, well, it's a little deeper hole, but so I just reran the program. Now, that's what this video is going to talk about, because while I was doing this, I was thinking there's a lot of people out there probably don't know they can do this, or don't understand how to do it, or they think they can do it, but they really just, don't know all the steps to do it. So we're going to create a program here in Carveco with it's just going to be a little circle, nothing major. It's going to go down a ½ inch. This board is 3/4 of an inch, and then we're going to move the origin. And then we're going to see about taking this bit, the top, the Z, and see if we can make that hole deeper. Now, why would we want to do that? The reason is because this board is 3/4 of an inch thick. And yeah, I know in an ideal world, you're going to go get another piece of wood that's going to be 3/4 of an inch thick, and you're going to be able to rerun that program again. But if you're making lanterns or signs or whatever, and you got to cut completely through the wood, there is a better probability that you're going to just destroy your wasteboard. So if we can recalibrate, take a caliper and re-measure this, and this is 0.75, and the next board that I'm going to cut through is 0.73. Well, what if I just raised that work origin point up 0.02 and then set it and said this is now my new work origin? Will that make a difference? Well, there's only one way to find out. So let's go get this program started. So in order to do anything with the CNC machine, and so we can go out and play around, we need some sort of a model. So I'm going to start a new model here with a width of 5 and a height of 5. My origin point is going to be down in the bottom left corner. And get back over to 2D so we can actually do something. Vectors, default layer is fine. I'm just going to put a circle down here. It just doesn't really matter how big you make this, because it's going to be put at 1,1 and the radius is going to be 0.25. So that gives us a ½ inch circle, because the radius is 0.25, so your diameter is 2 times your radius, gives you a ½ inch circle. Now we can get rid of this. Next thing we need to do is create a tool path. We're just going to do a clearance area. So before we get this started, remember, if you go up to material setup, you won't update anything down here. And I don't know why this is picking up like old values, but it does. So remember, go down to this material thickness at the bottom and click setup. So 0.75, going to run this up to the top. Oh, that's really messed up. We're going to take, keep this at the bottom, 0.75 for the top offset. This dialog box needs work. Let's just put it that way. So the model thickness is 0 inches, material thickness is 0.75, model position and material, the top of it is at 0.75 and the bottom I have at 0.0. Alright, so just keep that there. It'll tell you your thickness is 0.5. I think this should give us more information. There it is. So Z bottom is minus 0.75 and the Z top is 0, which seems to be a little backwards than this, but we'll go with it. So when you Z off at the top of the material here, when you Z off at the top of the material, this is going to be X, Y, and Z 0. So keep that in mind at this point right here at the top of the material is X0, Y0, and Z0. Forget about what all these numbers are above the cursor, but that's what it is, and that's what this is trying to tell you. All right, so let's go back to 2D view. So we're going to add a bit. The bit I'm using is a 1/4 inch. It's my tool number 4. If you need to set a tool number, you can go to Edit, hit Select, and we're only going to go down 0.5 inches. All right, because I don't want to bore all the way through the thing. So I just want to go down 0.5 inches. We're going to make this a 1/4 area clearance for my circle. And then you're going to see the toolpath get created. Okay, so now you can see that we have a toolpath, and if we execute this, you will see that it is not completely through. We have a hole that is a 1/2 inch deep, and it does not go completely through because this is a 3/4 inch piece of material that I have here. So what we're going to do is we're going to go out to the machine, and we're going to show you how to move this origin up to here and create another hole, or move the origin over here and create another hole over here. All right. So you can do that on the machine without coming into here and actually moving the physical hole. This helps out a lot because a lot of times when these are created, you might have a bigger piece of stock, and you might want this hole to be closer to the edge of the stock. So moving this origin around will allow you to get that, get your cut where you want it to be on that piece of material. So let's get this thing saved off now that we have it created. Put this stuff on, area clearance, it's fine. And now it's saved. All right, so we can move out to the shop now and get this thing loaded up. So the application that we're working on, or the G-code file, is in this Lars Workshop Step 1 area clearance. It's what we just created. So it's going to get loaded, and as you can see, it looks like the bat signal here. It's just a circle kind of out in the middle of the field. So nothing major. If we pop over to jogging and probing, because we have to get this corner down here probed, which is 0, 0 for X and Y, and that is right there. So we're going to get this guy probed. We've got a whole video up on how to probe and I got another video on the errors you can get with probing and, well, Masso errors in general. So the first thing you need to do is get this between the top of this and your stock. Kind of keep it over to the right of this thing, this little Elite symbol, the drill symbol there. Not real far, because otherwise you'll end up with an error. Over here, and we're going to pop back and forth between the video, and I'll try to go as slow as I can. So the probe diameter is 0.25. Make sure you save your settings. You don't need to do this every single time. I'm just reminding you, you need to save settings before you actually do your probe if you change probe diameter. So if your bit changes. So to do this probe, we want to touch, this is the actual probe block. We're going to touch this side, go over, and we're going to touch this side to pick up X and Y. And you'll see that happen right here. Just picked up X. And we picked up Y. I'm going to raise Z up. Scoot that over top of the probe block. And then we hit the center button on here. that button right there, and this is what this will happen. So you hit the center button, it lowers down, touches, the electrical current connects between this magnet and the block, and now we have our X, Y, and Z. We're going to go up to F4, Tools and Offsets, and then there is a G54. Now I've double clicked on this and named this Work Origin. Highly recommend you doing that, so when you come back here you know what you're looking at. This guy's Work Origin is 13.8 on the X, 4.26 on the Y, and negative 4.25 on the Z. That is what you just probed. So you just told the machine that my work origin is going to be residing at X at 13.8 from the machine's 0 and 4.26 from on the Y from the machine's 0. Don't worry about the Z right now. We'll get into that later. Okay, so if we go back to programming in MDI, you'll see the machine thinks it's at 15.4 and it's at 5.6. So let me zoom in on that so you guys can see this. This is where we're going to spend a lot of time in this video today. Is this area here, because that's the machine's location. This area here is the job's location. In order to understand how this coordinate system for the machine and for your job works, because there's a relationship between them that everybody needs to understand to be able to, well, do CNC programming and to be able to understand how to move a work origin offset, or deal with anything that's going on in your machine. There's 3 different points that we deal with. This point here is the X and Y 0. This point here is the X and Y and Z 0, or the home of your machine. So when people are saying, hey, I had a home machine because it didn't know where the point was, well, this is the reason. Because this is where your 0 is for your machine. 0, 0, 0 is right here, right where this tip is. All right. Now the other point that we need to look at is the one that's over here, and it's the work origin for your job. Now this for your job is 0 on the X, 0 on the Y plane here. So if I take a piece of paper and I set this like this, and you take this plane all the way up, I'm going to hit the center of the bit on this side. If I take this plane over here and bring it up, it's going to hit the center of the bit. So for X and Y, this bit is in the planes of X and Y. All right. Now it's still in the plane for Z for the machine, because the plane for Z for your job is the top of this piece of wood. Now, in order for us to see this, let me bring this down. Now that bit is setting on that top left corner of this piece of wood, right? Because that is the 0, 0, 0 for the job. So let's step back a second and think about this. Okay, so if we start from homing the machine, your machine's coordinates are going to be 0, 0, 0. All right. If you were to drop this bit down onto here to the spoil board on my machine, the coordinates would be 0, 0, negative 5.12, because the Z came down 5.12 inches. So we go back up to the home, and we were to hit work origin, it would zip over to this location, and it would be 13.8, 4.26, and 0 for the Z, because you're in the Z plane up here. This is the Z0 plane. All right. Now, if we were to bring this down to the top of the machine on the stock, right, that top left corner where it's setting right now, right here on that top left corner, that location would be 13.8, 4.26, and negative 4.25, because we just came down from the Z level here. But as far as the job's concerned, and this is what we're concerned about, is it is 0.00 because this front piece of the wood is X plane, its 0 is there, the Z 0 point is there, and the Y 0 point is there. So if you look at the pen, the tip of the pen, that's the center of the bit is lined up. There's a gap in between here because that's the outside edge of the bit. Alright, so here's the outside edge of the bit. You can see the gap. But the center of the bit, if I bring this up, you slide that under, you can see the center of the bit is lined up with that line on that 2x4. Okay, that bit of 2x4. Now if I pull this out, that's how far it is. So the center of the bit is actually on that little tip, that little point of that stock. And it's the same thing going the other direction. If I was to go this way, you would see it the same thing. So both the Y and the X is on that little tip. But we can change all this, alright? Now, the reason I'm setting this up is I want you to realize that this is the work origin for the project you're working on, not for the whole machine. So here on the screen in the machine area, so these are machine coordinate area, you can see that the work origin is X is at 13.8, Y is at 4.26, and Z is at 0 in relative to the machine being homed. Alright, so a little recap on this. So if your home is 0, 0, 0, that's up in the air in the front left hand corner of my machine, the machine for the work origin says 13.8 is the X, so we went 13 inches, 0.8 to the right, 4.26 to the back, and we haven't gone anywhere with the Z. Alright? And we can tell that by looking over here at the job. So remember, X, Y, and Z is for your job itself. So here's the job right here on the top corner of the stock is 0, 0, 0. So we are 4.25 inches above that job, the job's origin of 0, 0, 0. Alright? So at this point, let's kick this thing off. We're going to get it running and we're going to cut a hole. And that hole is going to be exactly 1 inch to the right and 1 inch back. Okay, so as you can tell, there's a hole that's 1 inches up and 1 inches from the left. And what we want to do is, without reloading a new program, without going back in, we just want to move this hole up because, you know, another inch. Alright, so we're going to move this offset, this work offset. So how do we do that? If we go back to the console here, the Y, we're just going to zero this out. 0, 0 doesn't really matter. So if we take the 0 for the Y and we tell it that position is negative 1.0, we hit enter. Now watch what happens to the bit. I'm going to say go to work origin, and it just moved away from us. Alright, I'm going to bring this down so you can see how far it moved. Okay, so we moved an inch back. So now this center is lined up with that. Let me adjust the let me do this again. Let me go back to work origin, because that's where it thinks work origin is, and let me put this back to, as you can see, this guy thinks that we're at 0 up here. Alright, It says -0, but it still thinks we're at 0. So let's say, nope, sorry, that was wrong. We made it. Let's make this 1.0 again. And now let's go to the work origin. So we're going to put it right back where it was. And you're going to see it's going to pull forward. All right? So that pulled forward. And now that says 0 up there. So say let's go to the right on the X. So let's take the X and say we are at -1.0. And that's what we are telling the computer, the controller here, that the point that we're at is that X is -1 and Y is 0. So let's make this here also, well, let's just go with the 0 right now. Now I'm going to say go to work origin. Okay? And it moved to the right. Now it's directly above that circle. Well, it's not directly above it. It's in front of it. It's right here. It's on this plane right here. But it is, the Y is on that plane. So if you wanted to make the Y, you wanted to get it right over the circle, you could put in here and put for the Y, right? Say -1, hit enter, and then hit go to work origin, and watch what happens. Now it moves back. Now if I go to job and probing and bring this down, I'm going to go right in the center of that hole. Alright? So that's what it takes to move the point around. Alright, so let's create another hole out there. So in order for us to plan to move the offset, we need to know what we want to do. So say we just want to drill another hole back beyond here, right? 1 inch back. So that's what this is correlating to. So we still have our offset currently sitting here for the job 0, 0, 0. And this hole is at 1, 1, 0. So this hole we want to move back an inch, but we still want to keep it in the same plane in the X frame here. So that's going to be 1, 2, 0 now. So what we need to do is we need to tell the computer that this job is no longer 0, 0, 0. We want this job now to be, the job origin, to be 0, 1, 0. Right here. We want this to be the job origin, right? Now in order to do that, you're going to tell the computer that this point is no longer a 0 here. This point is now -1. Alright, and this will make sense in a second. So if you look up here, and we tell the computer, this point is now -1. Exactly where this is at. Okay, so I'm going to drop down the Z like that. That point is X is 0, Y is -1, and Z is 0. So what's going to happen, I'm going to bring this up a little bit, when we come over here and we hit go to work origin, it's going to want to take this number here and bring it to 0, 0, 4.25, whatever it is, okay? So what's going to happen on this Y is that Y is going to become 4.3 because we're going to subtract this out. Now just watch what happens with the bit and we'll come back and talk about the numbers. Go to work origin, goes up, and it moved away. I'm going to bring the Z back down so you can see it, but here. First off, while we're sitting here, 0, 0, 4.25. Remember I said the Y would go to 4.36? And then watch where this is sitting now. This is now in line with that because we told it this was -1 on the Y. When we went to origin, it said I need to go to 0. Now look at this. Tools and offset now says Y is 4.3 instead of 3.3. because that's what we basically told it to do. We didn't have to redo the origin. We just said this is -1, and now it's going to get back to 0, 0, so that gives us our 4.36. All right. Now what's going to happen if we cut here? Let's watch. I'm going to go to work origin, straight up. I'm going to rewind, hit cycle start, and look at that. We're going to drill a hole 1 inch away from us for the circle. Okay, so now we have 2 circles because we moved this back. So let's do this with the X now. All right, so let's just go back over here, and we're going to hit work origin. And this guy says 4.36. We need to put this back where it was before we can put another circle to the right of the original circle. Okay, so if we want to put another circle right here, we have to tell the computer that this guy here is at position 1. Otherwise, if we move the X, we're going to put another circle up here. So let's just make this go to position 1. So we just go here and say, hey, you're at 1. And now I'm going to drop down the Y so you can see where it's at, or the Z. So you see how far back that is? That's 1 inch back, and if you look at the computer, it says it's at 0, 1, 0, or close to 0. So now when I hit go to work origin, it's going to come up and it's going to come forward. So when we bring this back down, we're back at this point. Now we want to move this over and say we want this to be 1 inch over and put another hole in there. So I'm hoping you guys are kind of following along with this now. For the X, we say that position is -1, so that we're going to move the X over to the 0. So when we hit work origin now, it just moved over. It came up and moved over. So let me show that to you again. If we bring us back over this way, and we just hit work origin. Now I bring back down the probing, and we're going to be in line with those circles again. Okay? So let's kick this guy off and you'll see what happens with it. Go to work origin, hit rewind, cycle start. And we're going to put a hole 1 inch away. Same program. This is all the same program. Okay, so what we have now is we have a hole here at 210 because we said the work origin, or the job, is at 100. So now let's put another hole up here at the top, and I should let you guys do this yourself, but so we need to put our job origin right there on 110. And that will give us a hole at 220. All right, so let's try that. So since we've already got the work origins already off for the X, we've already added to that. So let's just tell it that the Y is at -1 now. All right. Now go to work origin. And now we've got the 16.0 and the 4.3. Let's hit rewind and let's let this thing start. And now let's see what happens. Some of you may be asking, why, how important is this? How, what would I ever use this for? And one of the things is just doing some tests on some holes and stuff. As you can see, I don't have to go back inside and edit things. I don't have to move my diagram over to get, 4 different holes. I can just go in and adjust the depth that I'm cutting my holes in Carveco or Fusion 360 or whatever. I can just say, okay, I want this depth to be a little bigger, a little deeper, or bigger in size or whatever, and I can use more of the board for testing. Second thing you can use it for is if you ever have to add an extended board out here. So say you're making a ruler or a height chart that's 6 foot tall or 7 foot tall, if you have a kid that's going to be really tall, if you think they are. So you can you can cut out the first 3 feet, bring that down, find out where that 3 foot mark is. If you're putting in your 4 foot and it's going to be a foot away, which is fine on something like that, right? Then you can continue it a foot out. You can use this X and Y to adjust so you can keep your line straight and how far away it is. So play around with it before you go and cut something real, but play around with it, get it down so you can say, okay, I did print something 4 foot, now measure it out and go, oh wow, look, this actually worked. Offset movement on your machine is very key to understand. So now the second part is a little different. All right, it's messing with the Z height. So we've already done the X and the Y. Let's play with the Z height. And why would you want to do that? Let's go find out. If you look at this diagram here at the very first thing, say we have a board that is currently 0.856, which is what we have right here. All right, and we want to go down to say you're cutting out some lantern faces and you have a variety of different thicknesses of wood. I'm just going to pick that there's 2 different thicknesses. One is the 0.856, which is kind of thick for a lantern face, but the other one say is 0.75. So right now, if you're cutting completely through, say these circles, these holes were going all the way down through the wood, right? So here is the 0.0856. This would cut down to the bottom and everything would be fine, right? Your spoil board pretty much hits the bottom of it. You might have some burrs that come out and whatnot, but it's not going to be that big of a deal. If you were to cut this with let's go over this side. If you were to cut through this with the 0.75 and your program still said go down 0.856, you're going to bury yourself into your spoil board, right? Okay, so what we need to do is tell the controller that your piece of wood is actually thicker than this once you probe off on it. All right? That is, you're basically telling it that your bit is longer than it is, if you will, but you're going to run it shorter. So the difference between 0.75 and 0.856 is 0.106. So we need to tell the controller that your piece of wood is 0.106 thicker. Otherwise, what you need to do is you need to go back into your Carveco or your Fusion 360 or V-Carve or whatever and tell it to regenerate all your tool paths. And not everybody wants to do that. Now, so the Z-axis is no different than the X and the Y-axis. Say you're cutting out a bunch of lanterns, faces on lanterns, and your wood is, has different heights, different thicknesses. You can either go through and you can plane down every piece of wood and have them all the same thickness, and that would be great. But some people like them a little rough. Some people like, the way the cedar is. They don't want it really smooth like this. They want, a little bit of rustic look on it. So you're going to have pieces of cedar that are this thick and some that are this thick. So in order to make sure, if you start out with a piece of wood that's really thick or really thin, no matter which one you do, you can't really use the same program to cut these out. Because if I'm cutting completely through this piece of wood, and say it's 3/4 of an inch, right? Say this is 0.75, and I cut completely through this. Then I come over here and I probe my Z up on top of this, and I come down and I cut through 0.75. I'm going to end up stopping like right about here, and then I'm not going to cut completely through that piece of wood, and that causes you a lot more work. So likewise, if you were to do the same thing over here, and you were, say this is a 0.8, I think it's like a 0.865 thickness piece of wood, and we went through and we cut this completely through right down to the top of the spoil board, and then we switched out to this and we ran the same program, I would literally bury myself into that spoil board, this thickness right here. Okay, however thick this is, I don't know what that is. So it's like 0.106 or something like that. And I don't want to do that either, because I'm not really interested in replacing my spoil board every time or have to resurface it all the time. Yeah, I've got some things up here that I've, had some accidents with Carveco that's bored through my spoil board, but, these things you learn about, and you make sure you double check them every time. So the way that you can repair this is you got to figure out the very first board that you measured off and what your program tells you how thick the wood is, and make sure you keep notes of this stuff, like put a readme file with it or whatever, something to tell you how thick the piece of wood was. A lot of programs will kick out that information for you. You can do that if they're correct. So say the very first board you cut was 0.856, okay? That one's going to level down and you're going to be good. Now you got to pull that piece of wood out, you got to put a new piece of wood in, and the first thing everybody wants to do is they want to probe on X, Y, and Z. And the second you do, if that board is smaller and you probe that Z, you're going to bury yourself into your spoil board. Now, you don't really have a choice if you have to keep switching bits. All right, if you go from a 1/4 inch to an 1/8 inch, a 1/4 inch, an 1/8 inch, and a lot of us do that. There's a lot of details in these, lanterns that I do. So you're going to cut out the 1/4 inch stuff, then you're going to switch to the 1/8 inch, and you got to go back to the 1/4 inch. But you're working with a 0.75 piece of wood here when, so you went from the, the 1/4 inch to the 1/8 inch up here. I'll draw that 8 eventually. And then you're going to put the 1/4 inch back here, but you're going to have to Z that off on the 0.75 because you just switched out the 1/8 inch bit. So here's the simulation for you, and the simulation is we've got this piece of wood that we're now pulling out. We've already finished off this piece of wood. We're good with it. We got our nice little lantern on that, and we're putting this piece of wood in. So let's get this guy clamped down. Okay, so that's what everybody does, and the next thing you're going to have to do is you're going to have to come over here and go to probe the Z. You touch. Now, this is where the problem lies, is because now this piece of wood here is obviously thicker. And if I'm using this piece of wood's measurements for my cutting of a board all the way through, I'm definitely going into my spoil board. If I'm not, it's not a big deal. If I'm, going down, hey, we're going to cut this out a 1/2 inch, say we're only cutting in holes in this, that's a 1/4 inch. Yeah, cut a 1/4 inch all you want. I'm more worried about the spoil board. So, what do we need to do is we need to take the difference from this, and I know that this is 3/4 and that this is 0.856. So the difference is 0.106, and here's the math that I did. So 0.856 minus 3/4 is 0.106. So I need to add to this Z point 0.106. Otherwise, when I do run the program, I'm going to bore all the way through this thing, and I don't want to do that. So let's go and figure out how to put this math in here. All right. What I've done is I brought this as far down to the board as I can without, actually hitting the board. But what I'm going to do is I'm going to do some math on the controller. And it's not like the controller is going to actually do math, but we need to get to the jog and probing page right here and get into step mode, and we need to get this number at the top here, this guy, to be 0 or as close to 0 as we can get it. So the first thing we need to do is it's 0.07, so this is 0.01, so we're going to choose that, and we're going to keep going down until we get that as close to 0 as we can get. Like that. And that's pretty much as close as you can go, because you can only go to 0.001 and 0.0005, and when you hit that, you're going to be negative 0.6 for some reason. I don't know how that becomes negative 0.6, but I don't get it. So we're just going to zero that out. Now the thing is at this point in time, we need to tell the machine that this is negative 0.106 and hit enter. Now I'm going to drag this up a little bit. Let's go to here, and then we can bring this up 1 like that. Now if you take a look at this bit now, this bit, and I'm going to take the old board and set it in here, this bit can fit over this old board can fit underneath the bit now, and that's what we want. Okay, we want this to think that this board here is still the thickness in here. So if I was to cut a hole completely through the original board, right, this board, say these holes went all the way through, now when I cut the hole, it's going to stop at my spoil board. And that's what I'm trying to get this thing to do, is to stop at the spoil board. Now, how can we prove this actually worked? And the only way to do that is to run the program that we currently have. So let's just take this thing and go to program, go to work logon, rewind, and execute this thing. Now we're just going to cut the circle hole. All right. So if you notice, the very first time that it started to cut, it actually didn't do anything. It just kind of spun around there in a circle. So let's see how deep this thing actually did cut, because the other ones we know are a 1/2 inch deep. I don't know if you guys can see that or not, but it's 0.4005. So I will take that as a win because we did not cut 0.5, we cut 0.106 or more approximately, less than the original program did. So that means that this board would not have been bored through into my spoil board. So I hope all that makes sense. Hopefully everything in the video made sense. Hopefully you understand more about the work origin and work offsets and how the probing works and puts everything in G54. If not, and there's any clarifications you need on anything, drop a comment below. If you like the video, please click like. If please subscribe to the channel, and have a nice day.